If Mauchly's test of sphericity is non-significant, that is, the significance is greater than 0.05, the assumption of sphericity has been met. In this example, Mauchly's statistic for both males and females suggests that the sphericity assumption has been met. As a result, we read the sphericity assumed rows of the tests of within subjects' effects. Now this looks like a bit of a horrible table, but we don't have to worry too much about all of these rows. This shows the results of the repeated measures part of the ANOVA with the corrected F values. Now the output is split into sections that refer to each of the effects and the error associated with each of the effects. Now because Mauchly's test was significant, in other words, the sphericity assumption was met, we can use the sphericity assumed row. Now also because we've previously determined that there is a gender by time interaction, we're only interested in the time main effects for both males and females. As a result, I've suppressed all other rows that you may have in your own output. All you can see are the two simple effects for males and for females. Using a Bonferroni adjusted alpha level for two tests, which is 0.05 divided by 2, so the Bonferroni adjusted alpha level is 0.025, both simple effects, as you can see, are significant. Now the tests of the within subjects contrast table is always provided in the repeated measures, but it's not routinely used. So here we're interested in the two contrasts, specially selected to enable us to interpret the interaction. Level 2, which is post-test, versus level 1, which is pre-test, and also level 3, which is follow-up, versus level 1, which is our pre-test for both males and for females. Now this is highlighted in the above. Now if you assume that we had decided to apply strict control over family-wise error to maintain the 0.05 throughout, this would mean that for each comparison, it's evaluated using a further Bonferroni adjusted alpha level of the adjusted alpha used for the simple effect. So 0.025 divided by the number of comparisons. In this case, it's 2. Therefore, the adjusted Bonferroni alpha for the comparisons is 0.025 divided by 2, which is equal to 0.0125. Now reading these results, for females, the level 2, which is post-test, confidence mean of 62.4 is significantly higher than level 1, which is the pre-test, confidence mean of 30.6 with a p-value of 0.003. The level 3 follow-up confidence mean of 25.3 is not significantly different from the level 1 pre-test confidence mean of 30.6 with a p-value of 0.026. For males, the level 2 post-test confidence mean of 55 is significantly higher than the level 1 pre-test confidence mean of 31.4 with a p-value of 0.007. And the level 3 follow-up confidence mean of 41.8 is significantly higher than the level 1 pre-test confidence mean of 31.4 with a p-value of 0.005. So the confidence program resulted in significantly higher levels of confidence for males and females immediately after their intensive confidence training, but there was only a sustained increase for males in the 1-year follow-up. So see your text for how to write up this mixed ANOVA and how best to provide the write-up of this mixed ANOVA using APA format.